So in this question, it was saying that we have an organic compound whose mass is 0.50 gram, and in that we have AgBr, which is 0.94 gram. We have to find percentage of bromine in this compound. Means in the organic compound we have to find the percentage of bromine, and it is given that this organic compound gave 0.94 gram AgBr. So I think this is a very simple question. We have to find the percentage of bromine in the organic compound. So that has to be given by this thing, that whatever will be the what is the percentage of bromine in an organic compound. It is simply mass of bromine divided by mass of organic compound into 100. So mass of organic compound we already know. We have to find the mass of bromine. How will we find the mass of bromine? So from here we can find it easily. We need to find the mass of bromine. We have been given that AgBr is 0.94 grams. So number of moles of AgBr is equal to given mass upon molar mass. Molar mass of AgBr is 188, which is given in the question. So you can calculate it by your own way. I have calculated it like this. And once you get the number of moles of AgBr, you can easily calculate the number of moles of bromine from there, because in one molecule of AgBr we have one molecule of Br. Similarly, in 1 mole AgBr we have 1 mole bromine. So in this much mole of AgBr we will have the same number of moles of bromine. So once we get the number of moles of bromine, we will multiply it by the molar mass and we will get the mass of bromine in the organic compound. That you can see I have done here, and the answer is finally 80%. If we see in this question, the mass of the organic compound is given to us as 0.295 grams, and which gives 0.188 gram AgBr and 0.1435 gram of AgCl. This is not necessary at all, because the question is asking us about the percentage of bromine, and we know that the percentage of bromine will be calculated by mass of bromine divided by mass of organic compound multiplied by 100. Mass of bromine can be calculated easily by like, we know the number of moles of bromine, that we will multiply by the molar mass of bromine, and from there we can get the mass of bromine. So let us see how. So number of moles of bromine will be same as number of moles of AgBr. So that means 0.188 divided by 188. This is the given mass upon molar mass, and this we will multiply by 80, that is the molar mass of bromine, divided by molar mass of organic compound, and from there we will simplify it, and roughly we will get this, which is equal to like somewhere 27 or 26, and from the options we can see that it is option number B. Now if you want to understand what Carius method is, so Carius method is basically used for the estimation of halogens, for the estimation of sulfur, or for the estimation of phosphorus. Let me read it through, because sometimes they ask some questions like from the database like that. So for that we need to understand theory. So a known mass of compound is heated with concentrated HNO3 in the presence of AgNO3 contained in a hard glass tube known as Carius tube in a furnace. Carbon and hydrogen are oxidized to CO2 and H2. The halogen forms the corresponding AgX. It is filtered, dried and weighed. So this is the AgX, from where we can find the number of moles of X, and that we will multiply by the molar mass, and from there we can get the percentage of this X, means this halogen, and it's that simple. And we have already discussed, I'm going to discuss some of the questions related to Carius method in this video only, so watch till the end. Then we have this estimation of sulfur. A known mass of compound is heated with fuming HNO3 or sodium peroxide in the presence of BaCl2 solution in a Carius tube. Sulfur is oxidized to H2SO4 and precipitated as BaSO4, and we will understand about this method also later in the video. And questions related to this have been asked multiple times, and you also need to know what is the molar mass of BaSO4, for example. If you remember these things, it becomes easy for us to solve the questions even more quickly, although they are sometimes given in the question also, so we don't have to worry about it. For example, here is a question. 1920 gram of an organic compound when treated by Carius method gave 1398 gram of BaSO4. Calculate the percentage of sulfur in compound. We have to estimate the percentage of sulfur in the compound. Now we know that the molar mass of barium is 137 gram per mole. From there we will calculate the molar mass of BaSO4, that is 233. So you have to remember that the molar mass of BaSO4 is 233. Molar mass of SO3, the molar mass of SO3 is 80. So in 80 we will add 16, so that it gives us the molar mass of SO4, and we will have the molar mass of SO4. We already know the molar mass of Ba, so we will calculate the molar mass of BaSO4, which is 233. This you should remember, 233. Now we have the mass of organic compound, and we know that we have 1938 gram of BaSO4. So mass of sulfur will be the number of moles of BaSO4, because whatever will be the number of moles of BaSO4, same will be the number of moles of sulfur also. So number of moles of sulfur, which is given mass upon molar mass, multiplied by mass of sulfur. Okay, so from here we will calculate the percentage of sulfur, like mass of sulfur divided by mass of organic compound, and that will give us this. You have to understand that you can write this directly. How? Whatever is the mass of BaSO4 given, write that 1938 divided by the molar mass of BaSO4 itself. This is nothing but the number of moles of BaSO4, and the number of moles of BaSO4 is same as the number of moles of sulfur. So we have this as the number of moles of sulfur. Multiply it by the mass of sulfur, you will get this is the molar mass of sulfur. Multiply it by the molar mass, you will get the mass of sulfur. Given mass upon molar mass is equal to number of moles. So given mass is equal to number of moles multiplied by molar mass. That is what we have done. And this is the last thing which also came this year in 2026, and it's also an important thing that you should remember, that a known mass of compound is heated with fuming HNO3 or sodium peroxide in Carius tube, which converts phosphorus to phosphoric acid, which is H3PO4. It is precipitated as ammonium phosphomolybdate. This is ammonium phosphomolybdate, and you should remember the molar mass of this. I have written it here, 1876 gram per mole, approximately 1876 gram per mole. By adding ammonia and ammonium molybdate, alternatively phosphoric acid may be precipitated as magnesium ammonium phosphate, MgNH4PO4, by adding magnesia mixture, which on ignition gives magnesium pyrophosphate, which is Mg2P2O7. This is magnesium pyrophosphate. Now let us see a question related to this so that we can understand all this theory. This is not to remember, this is just for an idea. Let us see this question. 1240 gram of an organic compound containing phosphorus gave 888 gram of Mg2P2O7. By usual analysis, calculate the percentage of phosphorus in the compound. So we know that the number of moles of Mg2P2O7 can be calculated by given mass divided by molar mass. The molar mass of Mg2P2O7 is 222. Again, something that you should remember. I have calculated it here. So the number of moles of Mg2P2O7 is 4. So the number of moles of phosphorus will be 2 multiplied by the number of moles of this, which is 2 into 4, which will give you 8. So the mass of phosphorus in organic compound is number of moles of phosphorus multiplied by molar mass of phosphorus, that is 248 gram. Once you have the mass of phosphorus, you can calculate the percentage of phosphorus in the organic compound. So mass of phosphorus divided by mass of organic compound multiplied by 100, and here you have the answer. So I hope you understand this.